Okay guys, today you can see at the top of the video it's talking about determining characteristics of rational functions. I decided to do a video on this one because it's one where people, for whatever reason, don't pick it up in class that well, and it would be nice that if you could go back and watch this a couple of times, you can go through the several steps that you have to do to find like asymptotes and intercepts and everything, all the characteristics that you might find on a rational function. So we're going to go through a few of them here, and if you get stuck or you get behind any time, just pause it, rewind as much as you need to, watch it again so you can see the steps that we've taken to do that. So we're going to go through a few of them and see if we can find out some of those characteristics, which will make them easier to graph and to identify and to use when we're actually getting to them. So the first one we're going to do is this. They're going to be written as functions, so you'll have function notation for all of these. And you got your f of x, and it's going to have 2x plus 5 on the top on this one. It's just our first example. Is our numerator. Our denominator is going to be 2x squared minus 5x minus 12. Okay, the first thing I'm going to recommend that you do is look for a horizontal asymptote. The reason is because the horizontal asymptote is going to be easiest to see before you do any factoring or anything like that. So, like what I'm going to do here, in the horizontal asymptote, there's three different scenarios you could have. In this case, the horizontal asymptote is going to be 0. And because it's horizontal, it's going to have to be a constant function, y equals 0 in this case. Or f of x equals 0 if you wanted to look at it. But on a graph, y equals 0 would work. Y equals 0, and the reason for that is because the denominator has a higher degree than the numerator. Meaning the exponent on bottom is bigger. That's the quick and easy way to talk about that. I'm still getting used to the buttons on this, that's why it's shaking a little bit sometimes. From now on, what I'm going to talk about when I talk about the denominator and the numerator in these is I'm going to call that d of x for denominator, and the numerator n of x. Because you can see that the top could independently function as a function, and so could the bottom. But when we put them together, that's what gives us a rational function, rational meaning a fraction. So when we look at this right now, we've got the denominator with a higher degree. That is always going to give you y equals 0. The reason is because when x gets really big, like a million, the top is going to get huge, but the bottom will get huge at a much faster rate than the top. And that's why when it goes really far out to the right or the left on the graph, you're going to see it approach 0, the x-axis, when we go through that. So that's y equals 0. The second thing you're going to be looking for, and I would recommend at this point, you're going to factor the numerator and denominator. Now, in this particular problem, the numerator is linear, so I don't have to factor that at all, but we can factor the bottom. So I'm going to write down, like just to keep things nice and easy and consistent, we're going to factor n of x, but in this case, it's just going to be 2x plus 5. There's no actual factoring to be done. And d of x. When you factor 2x squared minus 5x minus 12, you're going to go through a few things. Now, I've already done that, so here's what I've got for the two factors in this circumstance. And when you do those, you can check them out and see, do they actually make sense? And if you distribute that back out, you'll see that it does give you 2x squared minus 5x minus 12. The reason we do that is to find out if we have any common factors. And as you can see right there, the top has 2x plus 5 as its only term. The bottom is its only factor. The bottom has 2x plus 3 as a factor and x minus 4 as a factor, but none of those factors are matches on the top and the bottom. So for that reason, what we're going to say is this particular function has no holes. So there's no common factors. Means no holes. Again, I'm still getting used to the pen on these, so like that. So we've figured out that this is going to be no holes. That doesn't mean it doesn't have asymptotes, like vertical asymptotes, but it doesn't have a hole in it. Like you're going to have to put the actual little open circle anywhere in this graph. So the next thing we're going to go to when we do this is we're going to be looking for the vertical asymptotes, if there are any. And what we do there is we solve d of x equals 0. So in this case, we're going to say 0 equals, and we've already factored it, so let's use the denominator that's factored. It's much easier to solve that. This is going to give us x equals negative 3/2. and x equals 4 for vertical asymptotes. That means at negative 1.5 you would have a vertical line that you can't cross. We would usually indicate that with a dashed line or dotted line on the actual graph paper so you could see that. And at x equals 4 you will have another one of those. So this graph will be separated into a left side, a middle side, and a right side, 3 different pieces of the graph altogether. When you go to the next thing, we're going to look for X-Intercepts. And for X-Intercepts, that's going to be familiar to us. We solve, so I'm going to write that, and we're going to solve the numerator equals 0. So solve n of x equals 0. And when we do that, we're going to have 2x plus 5 equals 0, which gives us x equals negative 5 halves. And since this is an actual point, we can go ahead and list it as a point. The only time this thing crosses the x-axis is at negative 5 halves. And when it's on the x-axis, that means the y value is 0. So there's my x-intercept right there. Finally, the last thing you're going to do is the y-intercept, and that's the easiest one of all. I'm going to go back to my original function for the y-intercept here, and for the y-intercept, we just replace all the x's with a 0 because that's what we want for the y-intercept. So what we're going to do is f of 0. And when we do that, it's going to end up being 2 times 0 plus 5. I'm going to move this down a little bit if it works this way. 2 times 0 plus 5 over 2 times 0 squared minus 5 times 0 minus 12. And you can notice that everything's going to cancel out except for the 5 and the negative 12. So my y-intercept is going to be 0 for x, negative 5/12 as a fraction for y. Those are the 5 things that you'll do for these to figure out what all the characteristics of a graph might happen to be. So you can see that whole problem from beginning to end, how it's going to work out when we do these. This is how we will find the characteristics of that. So this would be a good place to pause the video if you need to. We're going to do one more example of these to see what happens, and then pause the video at this point, make sure you got everything taken care of, and then we'll come back to the next problem that we're going to try. Okay, back to the next one that we're going to try, and this one will have a different kind of horizontal asymptote, which is why I really wanted to throw that in there. So the problem we're going to do in this case is going to end up being 6x squared minus 19x minus 7. So f of x is 6x squared minus 19x minus 7, all over top of, what did I write on this one, 2x squared minus 3x minus 20. Okay, and again, we're going to go through those steps because they're the easiest way to keep track of how you're actually going to find these important characteristics of a rational function. So in this first case, we've got, we're going to look at the top and the bottom. If you look at the numerator and the denominator, in this case, remember we call those n of x and d of x. So the degree here is 2. For d of x, the denominator, the degree is 2. Those are the same. And since they're the same, what's going to happen is if you put really large numbers in for x on the top and bottom, the 19x and the 7 aren't going to matter. The negative 3x and the 20 aren't going to matter when you're talking about huge numbers. They're not going to matter in the sense of it's going to approach whatever the top and the bottom do. So you only look at those 2 leading numbers. And what I'm going to do is highlight a couple of those things right here. When we look for this horizontal asymptote and they're the same, you can see 6x squared and 2x squared. Just divide those, and the number that you get when you divide those is going to be your horizontal asymptote. So 6x squared divided by 2x squared is going to give you 3. Now that's a horizontal asymptote, so that's going to be y equals. Okay, and there's our horizontal asymptote in this case. It's going to be 3 because 6 is 3 times as big as 2 is really the main reason. I think I got an email there. Okay, so for number 2, or the second thing that we're going to be doing with these, we're going to factor the top and the bottom. And you notice that these are both quadratic, so if they can be factored, we'll do that. If they couldn't be factored, then this part won't matter as much anyway because we're looking for common factors. So if they can't be factored, you're not going to have any common factors. But you do go ahead and factor the numerator and the denominator. And since I've done this ahead of time, when I factor those, we're going to have 2x minus 7 and 3x plus 1. And for d of x, we're going to end up with 2x plus 5 and x minus 4. So you can see out of the four things I just wrote, the four sets of parentheses, none of them on the top are in common with any of them on the bottom. And since they're not, we do not have any holes in this graph. So I'm going to go ahead and indicate that here. No common factors. Which means no holes. And as we get to the holes, you're going to notice that it's going to be an open spot in the graph, and we'll talk about how to deal with those when they happen. But we haven't seen it yet, so when we graph them, we'll do more with that. Okay, so with the third step that we're usually going to take on these, because this is a process we go through, we're going to look for the vertical asymptote. And we find the vertical asymptote, as you remember from the last problem, by solving the denominator right away. So the vertical asymptote, we got the vertical asymptote, we're going to say, and I've already factored that, so I'm just going to say 2x plus 5 times x minus 4 equals 0. The zero product property tells me that's going to give me x equals negative 5 halves and x equals 4. So I'm going to have two vertical asymptotes at negative 2.5 and at 4. And then you'll see those vertical lines when we graph them. Okay, the next thing that we're going to be looking at are x-intercepts, and then we only have to solve the top. So for x-intercepts, we're going to solve the numerator, 2x minus 7 and 3x plus 1. Since it's already been factored, that makes it a little bit easier. That's going to give me a x-intercept when I split this up with the zero product property. X has to equal 7 halves, and x has to equal negative 1/3. So those are my two x-intercepts, which you could plot those points. Those are actual points on the graph, which is why they're nice to find. The final thing that we're going to find is the y-intercept. I'm going to highlight a couple of things to find the y-intercept. Anything that has an x when you look at the y-intercept is going to go away. So you're going to see in this little blue highlighter thing that I put up here, that's a constant term, and that's a constant term. So down here, we're going to be looking at finding the y-intercept. We're going to have negative 7 over negative 20. And altogether, that's going to give us 7/20ths as the y-intercept, so somewhere there in the middle of the line. Those are the 5 big characteristics that we have to look for and determine what we've got. We're going to talk more about holes in another lesson, so we'll be able to talk about how to apply these to a graph and what they do, but you are able to follow these steps to figure out what the main characteristics of a graph are. So thanks for watching. I will see you in class.